So we're talking about iodine-clock reactions. So this is a practical, not required practical, but still very interesting to do in the lab because it's a nice reaction to start to study the rate. And clock reaction, it's called like this because it shows a sharp color change after a certain time has elapsed, right? It makes it easy to study kinetics because if you think about it, what is the kinetic of the reaction? It's how fast the reaction goes. So we're measuring the time. To measure the time, we need to use a stopwatch. So we need to be able to see a sharp change in color or a sharp change or anyway, something measurable so that we can actually stop the stopwatch and record that time. Okay. So this is done with a chemical reaction. Okay. It's basically a change in color that causes a delay in the color change of this reaction so that we can actually time it. And of course, when we talk about factors that affect the rate, most of the time we're looking at concentration. So how a change in concentrations affect the rate of reaction. So we need to time how long it takes for that reaction to take place, even though this is actually not exactly what we're doing with the iodine clock, because we're not looking at a reaction that goes to completion. So let's start thinking about the chemical reactions that are involved. One very common is the reaction between hydrogen peroxide and iodide ions in an acidic condition to form iodine and water. So you may be thinking right away, oh, but there is a color change. Iodine is produced. Yeah, it's true, but it's a gradual change because the product starts to form. As soon as as soon as the reaction takes place. So it's a gradual change in color, and it's also quite not a very sharp color, so it's quite difficult to record it. Yeah. So having this reaction, the aim of the experiment or the aim of the investigation is to investigate how the rate depends on the concentration of iodide ions. So there is, of course, the factor that we want to change, which is the iodide ions. This is what we're going to change. Everything else is kept the same. But now we need to understand how this reaction actually works. So what is mixed in this iodine clock is a solution of iodide, for example, potassium iodide, an acid, for example, sulfuric acid. We have another solution of the reactant, which is peroxide. And there is one more thing. There is another chemical reaction taking place, and that involves adding sodium thiosulfate, which is this S2O3 minus, to the reaction mixtures. This is because it reacts with the iodine that is produced in the first reaction to form iodide ion. The important thing is that as soon as iodine is formed, it's taken away by the thiosulfate. So to start with, we don't see a color change. We're going to get to that for a moment, but first I want to make sure that you understand how this apparatus works and what we are mixing together. So the hydrogen peroxide, which is the ultimate reactant, it's added to the solution with sodium or potassium, sodium thiosulfate, potassium iodide, sulfuric acid, water, and then the reaction starts. Very important. To see a sharp color change, iodine requires an indicator. That indicator is starch, because when iodine is present, so specifically it's iodine in its elemental form, it forms a complex with starch and forms this color blue-black. So some question may arise already, but if starch is present, iodine will turn blue-black right away because it's formed right away. But you know what? This is the rate determining step, which means that this step is very slow, but it's followed by this very fast step, which means that as soon as the reaction starts, this iodine that is formed, it's much faster to react with the thiosulfate than to form a complex with the starch, which means that all of this iodine is stolen, yeah, and it forms these products which don't give a color change. So what are we observing and why is the color changing? as soon as the um, the thiosulfate runs out, because iodine is always given in excess, so the sodium thiosulfate solution is always lower than the iodine. And when it runs out, then there is iodine that starts being present in excess. And this is what will cause the sudden color change. Okay, so let's recap the steps. So in step one, we are making iodine slowly. And to dive a bit deeper into this type of reaction, we have actually a redox reaction because we have the hydrogen peroxide that it's, as you can see, it's forming water. Yeah, but what is happening? So the change between hydrogen peroxide and water is a change in oxidation state from a -1 to -2 for the oxygen. So actually the hydrogen peroxide is reduced. The iodide, because it goes from iodide to iodine, I2, it's actually oxidized. So essentially is a redox reaction that is taking place. Okay, and then yeah, you can balance it. We can balance the half equations with the acidic solution. So that's the first step. It's a redox reaction, but it's slow. In fact, the second step, which is very fast, it removes the iodine immediately. And as we said, that reaction, yeah, is a reaction. Again, it's another redox between the thiosulfate and the iodine. Sorry, the one above I didn't balance it, but we'll switch to it. And then S4O6 2 minus. This is another redox reaction where this time the iodide is actually reduced, the iodine is reduced to the iodide. Okay, so this is the second step and it's very fast. But the reaction will wait and then suddenly turns black only when iodine is present. And iodine concentration stayed almost zero at the beginning because it's formed and then, as I said, it's used up quickly. But once the S2O3 2 minus runs out, then step two can't happen anymore. So the iodine from step one starts to accumulate, and suddenly there is enough iodine to form this blue-black starch complex. And this is essentially our clock. This is where we see the color change. And that's how we would stop the stopwatch and we measure the time. In fact, let's think about what we are recording. But before that, let's think what we're changing and what we're keeping the same. For every different run of the experiment, as you can see, we are changing the volume of the solution of potassium iodide. This is because we prepare a solution, a standard solution of a specific concentration, but then we simply add a different amount rather than making many different dilutions and add that. It's too complicated. But of course, this means that we needed to keep the total volume the same. Otherwise, the other concentrations also would change. So to maintain the volume so as you can see, the total volume of the iodine, it's always 5 centimeters cube, but the concentration will be changed because we add different volumes of the potassium iodide solution and different volumes of water. And this is basically how to make dilutions, right? It's that. Okay, then the results that we're actually recording, or before that, actually, remember that if you're changing iodine, everything else has to stay the same. So the hydrogen peroxide, the sulfuric acid, the amount of starch, the amount of thiosulfate, all of this has to be constant, of course, because otherwise they may also affect the rate. The thiosulfate maybe not because it's not the rate determining step, but it would change how much iodine it's taken away in the first step. That's why we need to, still keep it the same as controlled variables. But this is essentially what we're recording. As you can see, we have a weird number of the concentration of potassium iodide because, as we said, we changed the volume. We changed the volume and not a specific concentration. So we would have to calculate the concentration of that, and then we simply record the time for the color to appear. Then we need to calculate the rate, and the rate is calculated as 1 over the time that it's taken. So it will get a unit of S minus 1. Finally, having the concentration and the rate, we can plot a graph that shows um, how concentration and rate change. So from this graph, we can see the order of reaction, because if it's a straight line, we know a rate concentration graph, it will give us a first order reaction, which means that this can be done with many other examples of reactions. As long as we have like iodine that reacts with starch to make this complex, but we could use maybe even other indicators. So if you have an exam question where you have completely different uh, like completely different reagents, still think about, is a reaction that has a similar behavior than this one that you've studied, and then you can analyze it in a very similar way. Okay, so um, this it's I think it's a good practical to revisit it to study orders, because it's a little bit simpler compared to the continuous rate monitoring, which requires measuring the concentrations at different times. Because this one we do the opposite, we measure the time and then we calculate the rate at the end. Okay, so very important how to study this. Make sure you understand the different reactions. Make sure you understand when the color change happens. And I would suggest you also to analyze a little bit the results of these from the specimen, like the specification. What is like as the concentration is different, how does the time changes, and therefore how does the rate change? And this can give you an idea of the rate of reaction and therefore the order of reaction. How far are you with the notes? Do you need any clarification, or for now it's
Um,
okay?
no clarification. I can take photos of the rest of it and then do it after if you need to.
If you want to know, you know what could be good is that maybe you plot the graph instead of copying this down.
Okay, that's fine.
Yeah, just or because I mean, to be honest, I don't think you need the note, the the amounts.
Yeah,
Yeah, I think what is just important is to have the equations and to understand the steps.
yeah.
I
Okay,
think that's best.
I'll take photos of all of it and then I can decide
Okay.
after.
Yeah, exactly, exactly. I think it's a good idea. And you will see that in WhatsApp I sent you a past paper. And the first question is a long but very good one for this specific topic. So I think it would be great to try it. And then maybe for next lesson you can try that question. Okay, I
Yeah.
think it's good for both revising the rate and also for you to practice this topic.
Mhm.
Okay, great. Yeah, take pictures and then yeah, I think for today is more than enough.
Okay, yeah, I've got that now. Thank you.
Okay, super. Paras, thank you very much. I'll let you know if I can do any more anytime tomorrow, but I'm not 100% sure. I will know quite soon. But I will message you in case. Yeah.
Yeah.
Thank you, Paras. Bye.
Next time. Bye.